Good afternoon and Merry Christmas to you all, and welcome back to my workbench where I have another video of electronic stuffery. Stuffery, yes, that's a good word. Uh, right, anyway, so this is a motherboard, as you're probably mostly aware, for anyone who's ever seen one before, and these are some capacitors, and it should be quite obvious at this point where this is going, if the video title doesn't already give it away. Anyway, yes, well, okay. So, I have this board here. It's an Asus P5VDC-MX, revision 1.01G for anyone who cares. I want to use it for something, specifically because it is a micro ATX board, because it has an AGP slot, and because it's the fastest one I have out of all the available things that fit that criteria. It's not a particularly fast board or a particularly modern board, obviously. I think it's a it's LGA 775 socket, so that gives an idea of how old it is. But even so, it would still be useful for something which I wish to use it for, as I just said. Anyway, so moving along. I wish to use it, but obviously I cannot. Well, I could, but there is some problem with it. There's a problem indeed with the fact that the capacitors have started to fail. Specifically these two here by the RAM slots. They have bulged. And it's quite amusing, when I received this board, this one was bulging, and I thought, okay, well I'll replace the capacitors later and use it, and I put it aside for a bit, and when I came back around to it, I found this one here. It also bulged as well. So that tells you just how bad these things are. They seem to be failing, even though the thing wasn't even being used. They are specifically the KZG series from, I believe, the United Chemicon or Nippon Chemicon, and they are actually known to be quite a bad series from that brand, KZG and I believe KZJ as well. They are the brand is typically a very good brand, and I believe that all their other series of capacitors are actually perfectly fine, but these particular ones just fail pretty quickly. Especially if they're used a lot, or even if they're not used. There you go. Basically, most of the capacitors on this board are KZG. There's a couple of KZE and some Panasonic FL, which should be fine. There's KMG as well, I believe, which is also, perfectly fine. But the majority are KZG, and those are the ones I shall be replacing today. So obviously these ones are visibly faulty, they're both bloated. I can show you some close-up pictures of that, and you can see like the difference between a normal one and a bloated one. If there's confusion as to how obvious it is, sometimes it can be quite subtle, sometimes the top is completely blown open. It is worth noting, of course, that the capacitor does not have to be bloated to be failed. It's quite possible the thing could have dried out with old age and heat. If the rubber seal on the bottom leaks and the air gets in, the electrolyte dries out, the capacitor fails, you're not going to notice visibly from the outside there's anything wrong with it because it won't bloat up. But also the rubber bung at the bottom can push out and release the gas and release the pressure, so that the pressure comes out the bottom where you can't really see anything, and the top stays flat. So just because all these other ones have flat tops does not mean that they're fine. They could well all be faulty. In fact, it is most likely that they are all at some stage of failing. The fact that the board does actually post doesn't mean a lot. It just means they're not that terrible to stop it from posting, but stability wise it may crash a lot. I haven't tested it out or anything, I don't really want to. At this point in this current condition, the fact that it posts at all basically means to me, well, it should be fine. And if I replace all the other capacitors that are known to be bad series, then it should be perfectly usable. At least that's my hopeful intention. Anyway, if it does not, I will be annoyed, but that is the way things are. But we can't really do like a stress test and a stability test on it with known bad capacitors on there, because it could either damage the board or it could give false instability readings which basically prove nothing. So really the only thing to do is to do that. just replace them and hopefully it works. I suspect that this board will be fine and perfectly usable if I replace the capacitors on it. So I shall do that. There's not much else to say really. I'll turn my soldering iron on, get some solder ready, and I'll get this thing here, which is always useful. So this video probably won't be very interesting. I'm just going to be replacing all these and probably won't be saying much about it. So if you're not particularly interested in watching this for probably like an hour of me just saying random sporadic things and desoldering capacitors, then you should probably go and watch something else. I'm not entirely sure what to say about it. Oh, there is one thing, I guess. Asus boards, or Asus, or whatever you want to call them, they're a bit different to every other brand on the planet, basically, and pretty much different to every other electronic device on the planet in the fact that they mark on the board with the silk screen, they mark the positive lead of the capacitor with the white stripe or the white side of the silk screen print, whereas pretty much everyone else marks the white side as the negative terminal. So it's worth noting that if you are working on an Asus board and you wish to replace the capacitors on it, that you take note of the actual polarity and the way the silk screen works, because there's a few cases online, if you have a look, of people that have replaced them all, assuming that the white side was negative, and they've put all the capacitors in, but they've put them all backwards, and the thing runs for about an hour, and then the capacitors will explode because they're backwards, which is what happens when you do that, and it's not a very good idea. So that's probably worth mentioning for anyone who's considering working on one of these, has never done so before. It's a trap that a few people seem to fall into. Yeah, so anyway, aside from that, well, the actual process itself is not particularly interesting. Generally, it's easier if you take the CPU and cooler off, but I can't be bothered because I don't need to get at the capacitors underneath the cooler, and it's just going to be more hassle, so I'll leave it on there. The battery I've taken out, well, because it was flat anyway. Second-hand board, old board, you know, what do you expect? But it's probably a good idea to take that out if you are doing something. If there is a working battery in there, take the battery out, just to make sure, you know, there's nothing unlikely that it will actually be a problem. You could probably leave it in there, but, you know, I like to take them out. It's just a useful thing to do. Anyway, so this is a multi-layer board, obviously, so it will be harder to work on than a standard board. If you've never done this before, you do need to be aware you need a decent soldering iron, some decent temperature control, and a nice big fat bit on it. Good solder, using leaded solder usually helps. And having a desoldering gun is also quite handy. Not necessary, but quite handy often. Also, sometimes you can use hot air as well to preheat the board, and that can sometimes help, because sometimes these, well, in the case of, for example, the CPU area, there's a lot of big ground planes and power planes and stuff, and they'll take up a lot of heat, so possibly when I'm doing these ones I'll need to preheat it with this and make things a lot easier if I do that. So that's pretty much it. I'm not sure how long this is going to take. If it takes a really long time, because I'm not really in a hurry or anything, I'm probably going to do this quite slowly. I might just show a couple of methods first and just give some examples, and then I might just do the whole thing as a sped up thing, basically, because there may not be any point in doing it slowly. But first of all, let's start with let's start with the two obviously blown ones. They are 820 microfarads, 6.3 volts. Look like they're something to do with the memory, possibly just capacitors on the memory supply lines, or just random bulk capacitance on the board. I'm not entirely certain. Without a schematic, obviously, it's hard to tell. But they are in a general area of a couple of MOSFETs and what looks like possibly a controller chip, so they could be part of some sort of buck regulator or something. Although this here looks like the memory circuit, the power supply for the RAM, usually its own dedicated thing. And this is going to be the CPU supply, obviously, and this is probably the supply for the chipset. This could be the supply for the South Bridge. I don't know. Anyway, let's get to it and see what happens. So first of all, as with anything, it's always a good idea to add some fresh solder. So throw some fresh solder on there. And there's a couple of ways of doing this. You can use the most basic method, which is does not require any special tools apart from a actually that won't work for that one because it's stuck between a RAM slot and a ATX power connector. But we could try it with this one. So what I'm talking about is the solder splash on the board. I have to clean that up afterwards. Yes. Anyway, so one method is the heat and pull method, basically, or the heat and rock and pull out. So basically what I'm going to do is I'm going to push the capacitor towards that way as I heat up the lead that's on that side. So I put my finger under there, heat the lead up, push the capacitor sideways. And you can see, hopefully, now the capacitor is on an angle. Maybe you can see that, I don't know. Anyway, push it slightly on an angle, and then you can do that with the other side. Pushing it back the other way. Don't push too hard, obviously, you want to wait until the solder heats up. And you'll feel it moving slightly when you do. And then you can heat the other side. And do it again. And basically you just rock the capacitor back and forth, alternately heating the other side, the legs, until eventually it'll fall out. Just like that. So that's the first way of doing it. That's the easiest way. In some respects, you only need a soldering iron and your finger. That's one way to do it. The only problem is it leaves the holes full of solder, and then you have to figure out how to get those out. So that's the question. How do you get the solder out of the holes? Well, there are several ways of doing that. One method is to use solder braid, which can work. Does not necessarily work on multi-layer stuff when there's a huge ground plane. It'll work fine on multi-layer stuff if the hole is just connected to a small trace, for example. It usually works fine in that sort of scenario. And as is the case with the leg on the left side here, it probably will work for this one because it was very easy to heat that one up. So, you know, you just lay your thing on there, and in fact the hole there, that's actually cleared perfectly fine. So, assuming there's no big thermal mass on the hole, I'm just going to do the other one. Some more free solder on that. And we can try this one, which probably won't work because it's connected to a ground plane on the other side. Yep, didn't work. So if I tried to use the braid on that multiple times, I'd eventually just ruin the board. So that's not going to work for that one. It worked for the other hole, but not for that. So braid can work. It may work, may not. Just depends on how the thing is. If you preheated the entire thing, then use the braid, it'd probably work, but it's just harder. So there's another option for that, One option is to not bother actually clearing the hole at all. What you can do is get your replacement capacitor, and this does help if you've cleared one hole but not the other, but it can work too if you haven't cleared either one. And basically what you do is you take the capacitor, you cut the leads short to about the same length as the original, which is about 3mm. And then you place the capacitor on one side, again making sure that the polarity is correct. Again, the white side of the circle is positive in this case. And if I heat that one, if I heat the negative side with soldering iron on one side, a bit tricky because it's not necessarily going to work that easily. This particular one is quite tricky. I might have to suck a little bit of solder off from this side. Just to give a indentation to sit the lead in. But if I was to sit that like that, and then put my soldering iron on the opposite side, sometimes possible to heat that up and the capacitor just pops in. So that's now in there, and basically you don't actually need to clear the solder out, you just need to heat it up enough to poke the hole through, poke the lead through the hole. And then you can resolder the other side just normally, because that one is the easy side. And it's a good idea to just reflow the other side just a little bit if you can. Add some fresh solder there. And basically then you don't even have to trim the leads because you already cut them. So there's that way of doing it, is just a heat it up, pull it out, heat it up, push the next one in. Can work quite well, as you can see. No special tools required. And just a soldering iron and some solder and some wick, but not necessarily. It does help to use that. You can, in case there's a bulge on the other side of solder, to flatten that down so you've got something to orient the lead into. I'm just going to have to clean up all this solder that I've splashed on the RAM slot here. That's not particularly good. There we go. But yeah, that's the first way of doing it, basically. Of course, with this one, it'll be harder to do it with this because it's jammed between the RAM slot and the ATX power connector. So it's doable, but it will take a bit of time, take a bit of extra time. So instead, I'll do that with the desoldering gun, because that's another option. If you do have a desoldering gun and you kind of need one like this rather than the one-shot type, you need the vacuum one. Basically just do it as you desolder anything. You put this over the lead, is this this? No, this is. Need to turn the temperature up, I think. The main problem with this thing is the temperature adjustment is a bit weird. It's a bit the knob for this is flush with the bottom of the thing, so it's quite hard to actually do anything with it. Anyway, but you can let's get this on here. Hold the capacitor on the other side with your finger and add the heat, move it around, and start wiggling the capacitor and the lead, and you can feel when the capacitor starts to wiggle more freely, that's when you can apply vacuum. If you do it before then, obviously it's not actually free and nothing will work. And then you just got to do that to the other side. Again, hold the capacitor, wiggle the thing. When you feel everything is loose, apply vacuum. And if we take this around the other side, we can see it just pops straight out. No issues at all. Don't have to bother wiggling it. So that's the other method. Just use a desoldering gun, which is arguably a lot easier. But of course, you have to have a desoldering gun, which can be rather expensive. But if you do a lot of these things, or just like to work in electronics a lot in general, they're quite worth it. So, what have we got? And of course, at this point, the holes are both perfectly clear. There's no solder in them at all, so we don't have to bother trying to get the solder out or anything whatsoever. We can just grab the new capacitor and shove it straight in. And it's an optional thing whether you clip the leads or not. Personally, I actually like clipping them first when I do motherboards a lot of the time, because it basically just has less mass to heat up. If you have the whole lead sticking out in cold air, then it's just more stuff to have to heat up when you put the new capacitor in. And because these things are already harder to work on, given the multi-layer nature of the boards, it's a lot nicer if you don't have to worry about that sort of thing. So again, trim the leads, about 3mm long is the general thing, and if I can align this with the actual holes, I've got my side cutters might need replacing or sharpening or something, because they've kind of squashed the leads a little bit. Damn. But otherwise, there we go. Let's plug the capacitor in. And solder it in normally. Another advantage to trimming the leads first before you solder them is that you're unlikely to cause any stress fractures from cutting next to a joint, and you also do not have an exposed cut piece of lead sticking out to corrode basically further on, because the leads are obviously plated in the factory, and when you cut them you're breaking through that plating, so it does provide a better, arguably slightly more reliable connection if you cut them first and then have them coated in solder afterwards, so there's no exposed bare metal to corrode and cause a problem later on. But that's kind of really only I mean for a cheap computer motherboard it's not really necessary. Typically that kind of thing is only really done in military grade applications, so it's not really a major issue for a cheap motherboard, but it's something you can do if you feel like it. And it does make things a little bit easier sometimes. There are two other methods of doing this, of clearing the holes, aside from using wick. One is to use one of these vacuum pump things. And if you do use one of these, use a small one with not too much suction, because otherwise you can damage the board again. For example, if we try that on, let's try this one here. If I mean, this one's going to be a really easy one. It's not next to any power planes or anything. I wouldn't need to use this method on this particular one, but just for an example, I'll give it a try. So if I pull this one out, I can try and heat both leads at once, possibly. Yep. So there we go. I could heat both leads at once, pull it out, and that's good. But of course the holes are full of solder, so I can't put the new one in unless I heat them both at once and push it through. But one option is to obviously use the desoldering thing like I just mentioned. So you can set the board sideways. Obviously helps that I've got the cooler attached to it. I can just prop it up with that, but otherwise if you didn't, you can clamp the board or something, because you kind of need both hands free for this. But basically the option is you put the desoldering pump on one side, you heat up the joint on the other side, and then you just hit it. And because this one's not on a power plane or anything, that hole should have cleared. It hasn't. Yeah, it's not a very good method. It can work, but it doesn't always work. I think that one's worked. Yeah, we cleared that hole. So let's try doing the other one again. Maybe I had too much solder on the iron, or the tip was over the hole. Let's yeah, that's cleared. That's worked. But again, this is on a lone capacitor that's kind of by itself. There's no big power planes. This one's just connected solely to some really tiny traces. So you know, that's quite easy. But that is another way of doing it, is to use one of these. You heat from one side, suck from the other side, and that works quite well. We can put another one in. In fact, in this case, I'm going to cut the leads after I put it through, because the looks like my side cutters are a bit blunt or something. Which is not particularly helpful. The other problem I have, obviously, is the capacitor falls back out again, because the thing is there. So an option to deal with that is to get a little bit of tape of some kind. Doesn't really matter what kind. And you just sort of put that over the top of the thing and tape it to the board, or something like that. So that'll keep it in place while I solder it in. So that's another way of doing it. There is a third method to clearing the holes, which I don't personally use much myself, but is a plausible method. Some people do use it quite a lot. and that's to clear the holes out with a needle or a dentist's pick. I think is something that people quite often like to use. You can also use maybe the flat end of a drill bit as well. But basically what you do is after pulling the capacitor out with whatever method you want, like I said, usually the heat and rock side to side and pull out, or heat both leads at once and pull it out. Once you've done that, you heat the obviously you'd say, let's imagine this is imagine this lead is a needle. Obviously you'd have a handle for it, otherwise you'll burn your fingers usually. But once you did that, you'd heat the board on one side, just like I did with this, and then you push the needle through the hole from the other side, and it pushes the solder out through the hole. Obviously it's very important to use a stainless steel needle of some kind, otherwise the solder will stick to the needle and then you just have a needle stuck soldered in a hole, which doesn't really help. But if you stick a stainless steel needle through the hole, twirl it round as you wait for the solder to set, the solder will not adhere to the stainless at all, and as you're moving it round it will break any small connection which may be formed, and it will leave you with a fairly open hole. So that's another possibility. I don't really have anything to show that with. Yeah, I could probably try it with a small drill bit, possibly, just as an example. These are going to be probably, I don't know, 0.8mm holes, I assume. Worth noting though, what you should absolutely not do is drill the hole out. It's quite tempting if you have a hole that will not clear to grab a drill bit and try to drill the solder out, and that's not necessarily a bad thing on, say, a single-sided board. It would work perfectly fine, but it's not really necessary for that. The problem is, it's very likely you will cut through any interlayer interconnects to that through hole and basically destroy it. If you know for a fact that the hole only connects on the two outer layers where you can solder on and there'll be no problem, which is maybe fine for like a double-sided board with really large pads and stuff like that, you may not have an issue. But with something like this, you don't know how many internal layers. I mean, this board is going to be like 6-8 layers possibly. You don't know how many internal layers, traces, anything connects inside that hole. So if you start drilling, you can quite easily cut connections to that, and then you've ruined the board basically. So that's a really bad idea. Don't do that. If you, like I said, if you use the blunt end of a drill bit just to push the solder out while it's liquid, then that can be fine. But if the solder's hard and you've taken a drill to it, yeah, not a good idea. Certain circumstances might be perfectly valid, but in most circumstances, especially on multi-layer boards, it's a very bad idea. So I'm going to attempt to demonstrate that method. Not the drilling and ruining things method, but the just pushing stuff out with a pin needle thing. I'm going to attempt that on this one here by this USB connector. So once again, I can probably just heat both these pads at once and then just pull the thing out. Yep, that's worked. Okay, so that's fairly easy, and again we have the holes full of solder, so the idea obviously is to just heat it from one side. I don't know if this is going to work because this drill bit might be a bit too big for the hole, but if I yeah, just push that through. This is actually the perfect size, 0.8mm. We just sort of push that through, twirl it round, and it doesn't stick at all. And holes have been cleared perfectly. So that's another way of doing it. Obviously it won't be that easy if you're doing it over here with the CPU VRM section, because there'll be big ground planes and everything, but for something like this, worked really easily. A needle is probably more useful because there's a pointy tip on it, so if you are in a hard area like this where you need to do kind of get a little bit of force on it, I say a little bit of force, you don't have very much at all, but yeah, if it's possible that you need to do that, it's potentially a quite a useful solution. We won't go through as easy as what I just showed, but it's can be quite good. And this one I think is so close to the edge of the board, I don't need to tape it or anything. Just the fact that it's sitting on the table should hold it in place. And I can just solder that in. So yeah, there are... Whoops, that's not straight at all. There's another problem you can get if the capacitor's not straight. I mean, this is connected, so it doesn't really matter, but I just want to be pedantic about it, so just reheat and push down on it until it goes through the hole all the way. And maybe add some more solder just in case. There we go. So that one's done as well. Yeah, that's pretty much the majority method. Like I said, aside from a big soldering iron or a soldering gun, which you can heat up both things at once and then just pull it out and then push it through, which I can't show you because I don't have one. Those are the main sort of ways to do it. Of course, these are all fairly easy ones, being on the outside of the board. The hard ones will be these ones here. So, and just so I don't make this thing really long, I might stop here, I might just cut it here or something, or just speed up the next bit, and then come back when I'm doing these harder ones just to show you maybe doing some preheating for that, because it might be a lot easier if I do it that way. But yeah. I'll probably do this one with the desoldering gun because it'll be a lot easier. Again, if you have a desoldering gun, it's easier to do it with this. Than with the soldering iron. And it just falls out, which is brilliant. Stick it through. And of course nothing special about this is solely for motherboards. This applies to any multi-layer equipment. Should I say any equipment with a multi-layer PCB? You notice I leave the soldering iron on for a little bit after I flow the solder in, just to make sure that the solder does all melt mostly down through the hole. You don't really want to have it just soldered on the back side and then whoops, a little bit of a solder spike there. You don't really want it to be just soldered on one side and all the way through, especially in something like the VRM section, which is ironically the hardest part to do that with, but this is where all the high currents are, so that's where you want to try and get the solder to flow through as nicely as possible when you are doing that. But anyway, so basically I'm just going to keep going with that. like I said, there's no other techniques I think I can show you. I've pretty much shown everything that's possible with what I've got. Yeah, the other obviously thing is to these are all 820 microfarad. I already know that because of the the things I've ordered, everything I've already done with it. These are all the same ones, so I don't need to worry about getting them mixed up. But obviously, you want to make sure that everything is you're not going to replace ones with the wrong capacitance or wrong voltage, which would be worse, especially if you accidentally put a lower voltage on a higher voltage rail, and that'll blow it up as well. So be careful that you are putting the correct ones in the correct places, and that you've got them around the right way. It's obviously a good idea to write down everything, maybe even take a photo and then label it of what values go where before you start, because I do see one thing that people do is they sometimes pull all the capacitors out without writing any of them down, and then they don't know what goes where afterwards, which can be a bit of a problem. And then you have to go online and find someone else who's got the same board, and hopefully they can tell you what goes where. But it's not fun to have to do that. This is where the tape will come in handy. Obviously you don't have to get them perfectly straight, but it's obviously does help if you get them closest to the board as possible, because that reduces the effects, the lead inductance, reduces the resistance of the leads. Everything short as possible is best for especially with in switching sections like the VRM area. So you really do want to get the thing. Don't try not to do silly stuff like solder the capacitor sideways with one lead bent over and really long. That will probably work, but it's not the ideal. It's not the ideal solution. These ones are 682, aren't they? 680, I keep thinking 680, I'm confusing the 6.3 volts with a 680 microfarad. These are all 820 microfarad. Except this 470 microfarad Panasonic over here, which is an FJ, which again I won't be replacing because Panasonic FJs are perfectly fine. So I'm just going to do these KZGs down here by the PCO slots. That one, I don't know, that seems to be some sort of filtering cap for that PCIe slot. So yeah. Anyway, some dust on this, I've got to brush off. I could probably do all of these at once. There's 5 of them. 1, 2, 3, 4, 5. Okay, so I decided to skip a little bit there. This is the final bit. This is the last two capacitors to replace. Took a while, you know. Just I thought it would be much more sensible just to skip this whole thing. Otherwise, it's just a huge video, and yeah, there wasn't really anything else to say. What I already said. So there is a difference here, though. With these final ones here, I have purchased capacitors which are a larger diameter than the originals. Now these are 10mm and the originals are 8mm. That's not usually a terrible problem. For example, these ones here I kind of mounted on an angle because that was the only way to fit them, and that's perfectly valid as long as they're not, you know, stuffed in there super tight that things are getting strained. But in general, it's usually you can fit a couple in there just alright without any issues. So that's what I'm going to do with these particular ones here. Just these two here, and then this four here. I'll show a photo of what I mean. Also, another thing with these, the diameter of the leads, not the diameter of the lead, but the diameter of the capacitors mean that the leads are actually further apart than the originals. So I have to bend the leads, form the leads slightly to get them to fit in the holes properly. And there is another thing to note about that. Obviously, you could just bend the leads slightly in and then just shove the capacitor in the holes, but doing that is likely to cause strain at the capacitor where the terminal enters the body of the capacitor. So it's a much better idea to actually form the leads, taking a pair of like needle nose pliers and bend them over slightly and then bend them back so that you've got a kind of a little sort of a kink in them, diagonal sort of thing, and you can get the leads closer together without actually bending them right at the body of the capacitor. And I've got a couple of close-ups to show what I mean by that. Yeah, so obviously it does increase the lead length slightly by a millimeter or so, but probably shouldn't be really an issue. Like I said, it's really an issue more if you have the leads full length and the capacitor hanging out like a centimetre or two off the board. That's when you could get problems with extra lead inductance and all that sort of thing. But as long as they're like within 1 or 2 millimeters to the board, close flush to the board, it shouldn't really be an issue. And besides, I mean, with these ones, it is common to have to buy larger diameter capacitors and to mount them slightly on a lean, which means they will be a little bit further away from the board, but you know, it's only 1-2 millimeters at most, probably 1.5 for these ones will be, so it's not really an issue. Something that can usually be done without a problem. Obviously just make sure that you don't cut your leads too short before you put the capacitors in, otherwise you know, because of the slight diagonal lean on them, and there will need to be more lead length, just a little bit, like I said, 1 or 2 millimeters at most. But yeah, it's a good idea to try to get ones the correct diameter if you can, but sometimes it's not possible. Sometimes they're a custom size, the originals, or perhaps they're a size that isn't manufactured anymore, and you may not want to get the same series. For example, I could get a KZG with the same series, but obviously that would be just probably a bad idea because it would just fail again. So it's a good idea to use a different series which may not have the same value in the same size. So you know, sometimes it's just inevitable that you might have to try and cram something a little bit bigger into the board there. Obviously don't go too far up in size, because you can also get problems with actually the lead diameter can become larger and then it may not actually fit in the hole at all. And that is not necessarily an issue on single-sided boards, obviously, because you can, provided the pad is big enough, you can just drill the hole slightly bigger and it's not really an issue. But on something like this, as I mentioned earlier, if you try to drill a bigger hole in that, you're just going to destroy the board, so not worth it. Anyway, so I'll show you the final replacement of these two particular ones here. I've actually already done everything else, so I'll show the method with this, because this is in the VRM section. It's harder. It's actually easier to do it this way with the heat and pull method. And I'll show you the another way of using the drill bit backwards, obviously, not as a drill, but as a pushy stick thing. I can show that other method, because the previous one I showed was to do it from opposite sides of the board, which doesn't always work. It is a little tricky. I mean, it works, but it's a little tricky, especially for really tough ones. Like, for example, this one here is not that easy to get out. So, if I take a look at that, none of these holes are cleared. I've taken the capacitors out, but the holes are not cleared at all. So to put the new ones in, I have to remove these solders from the holes, and the easiest way to do that, because it's tough, because it's a bit tough, I'll just use the drill bit backwards. So you can also do it from the same side. You need to get a bit of solder on your iron and heat up, and need a little bit more solder. You need a decent solder bridge blob to get the heat through, to heat up the drill bit and the or needle, whatever you're using, to go like that and push it through from the other side. So you are going to heat and push from the same side, because, for example, with in this area, like I said, the way everything is, it's a lot harder to do it the other way. So I could try to clear all of these with this, but that will be a bit difficult again. So what I will do, I'll just clear the easy side, because generally one side will connect to a big ground plane and one won't. Sometimes you get unlucky and both leads connect to a large plane, but in most cases, especially on motherboards, you often find that one lead, usually the negative lead or the positive lead, I guess it doesn't matter, it depends on the part of the circuit, but the lead will connect to a big ground plane, usually only on one side, and I don't mean one side of the board, but only on one side of the capacitor in electrical terms. So you can usually just clear one hole, like I did with the drill bit there, and you can just push the capacitor through for the other hole. So to make that easier, it does make sense to flatten any solder that's on the capacitor side, and then again these ones will have to go in on a bit of an angle. So we take the capacitor here, get everything lined up, apply heat and push through. So we only have to do one lead like that, obviously, and I've left it just a little bit off, so I've got enough space to do the same thing with the other one, which again is going to be a little tricky. To some extent. And you can see, obviously, this is on a little bit of a lean, but it's not a big deal. Sort of push that over there. Make sure I clear the auxiliary 12-volt power connector, but it should be alright. They're as close to the board as I can get them in terms of connection there, but yeah, I can't really go any closer because they just won't physically fit next to each other that close. There we go. Let's put a big nice blob on there, which I can clean up a little bit later. And there we go. So those are in there. Yeah, they're a bit stuck in there a little bit. I'll show a close-up of that so you see what I mean. They're obviously not perfectly flush, they won't be because they're too big, but they're close enough that should be fine. So I'll insert that. I'll just make sure there's no bits of solder on the bench there. And obviously you should check if you have time, make sure, well, you should check definitely, not if you have time, you should check, of course, definitely check, no matter what. For example, I've just noticed another solder splash on this PCI slot connector, so I'm going to have to work that off. Don't want to short out things like that, because then we could destroy the south bridge with a shorted power to signal or something weird like that. Anyway, and then you can just go around and take your magnifying glass or loop or whatever and just inspect every joint you've just done to make sure there's no obvious shorts or anything, or or a solder joint you've missed. You don't want to have just a lead that you haven't soldered in. You just go around the board, check everything. You might want to have an extra bit of light here. But yeah, go through everything, have a check, make sure it's all working, make sure everything's been done properly, and generally, yeah, and of course you can clean the flux residue off as well. I won't do this right now, I might do it later, but I don't have any cleaning stuff at the moment, and generally, it's just rosin flux, doesn't matter, it's not going to do anything to the board, so you can pretty much just leave it there. It's only in sort of like really, especially for a power rail capacitor, it's not a big deal. This flux won't destroy the board, it won't corrode it or anything, it's very mild, and it's not going to upset, if you're doing work around like signal lines, low voltage signal lines and stuff, you might want to clean the flux because it might add some extra capacitance or leakage that could upset the signaling. But in terms of like a power connector and capacitors and stuff like that, it's not a big deal. So anyway, so now that's done, hopefully that was useful to learn how to replace capacitors on a motherboard. Show you some different ways of removing them and putting them in, how to clean the holes out with various things like wick, which doesn't usually work on a motherboard, but still can be useful for things like flattening off solder bumps and stuff, and obviously for wicking up splashes if you get stuff around in the wrong place. The little blunt drill bit, backward facing drill bit, or a dentist's pick or stainless steel needle of some kind can be very useful for clearing out holes. Obviously the desoldering gun, also very useful, and soldering iron, obviously you need that anyway. But yeah, there's various different ways of doing this, and you don't need all the fancy stuff. You can get by with just a soldering iron, and you can just, and some solder, just heat them up, pull the capacitor out, heat it up again, push the new one through. It is possible to do that. That's the simplest, sort of easiest, basic way to do it. I say easiest, it's not really the easiest. If you get a tricky part, for example, I didn't actually record the whole thing, but there was one of the ones by this USB port was very difficult because the thermal sinking of these port shields was sucking up the heat quite a lot, so I had to get my hot air tool and preheat that area quite a bit before I was able to solder those capacitors. So that's sometimes it is necessary to have the extra stuff. Of course, if you didn't have this, you could use a hairdryer. That can also work. It also helps now that it's summer here, so it makes this stuff a lot easier. I have noticed in winter it is a lot harder to work on these boards. So having good heating in that is definitely helpful. Anyway, so now that it's all done, that's pretty much it. Don't think there's anything else to say. I'll tidy this all up and put this thing, put some RAM in this thing and a video card. Well, actually no, I don't need a video card, it's got onboard, so I'll put some RAM in it, hook up a power supply, hook it up to this monitor, do a quick test, and we'll see if it still works. It should do. It worked before, and like I said, most of these capacitors might still actually be fine, but again, leaving them in there is long term. They're a known bad series, so it's just pointless. They'll fail sooner rather than later, and we already saw 2 that blew up just by themselves without even running. So anyway, oh yeah, and of course put a new battery in, obviously. Apart from that, yeah, new battery. I think I got some here. There we go. So yeah, put a new battery in, and oops, put that in, and now I'll find some RAM and I'll hook it up and see if it still goes. Alright, so we've got the board all set up to test out, and also got the old capacitors here. I'm just going to have a look at these for fun. So let me just check, is that zeroed? Yes, that is zeroed. Okay, so I've actually checked all the other ones, and they were all actually perfectly fine, or at least in terms of ESR, they were perfectly fine. These are one of the faulty ones. This one has, for example, 2.5, which is terrible. It should be 0.01 or thereabouts, or less possibly. And this one is 1.6. So, you know, not super terrible. In fact, these are probably for, well, I don't know what these are for. They could just be bulk filtering. I don't know. If they were, then I would explain why the board is running fine, despite the fact that these two were bloated. Obviously, it's still worth replacing all of them anyway, because, like I said, that series KZG known to be pretty bad, and yeah, so probably worth it anyway. But that's good. So it does show us that the board, if it doesn't work now, it means that I've done something wrong. And hopefully that won't be the case, but hopefully it does work. So we've got this power supply here, all plugged in. We got the green light here, I'm not sure if you can see that. We got the 5 volt standby light here, so that shows that the board at least is getting that, and that's working. So to start the board, I don't have a power switch connected, so I'll just short the power switch connectors together, and it should come on, and we should see the BIOS and everything on there. So it's running. See if it does anything. I've got a gig of RAM in there, so we should see that much. Although of course if the battery's been flat, it may need to be cleared, so in fact there's nothing's actually happening. Which is pretty funny. Let's try doing a CMOS clearing. It might be expecting an AGP graphics card, I can't remember. Let's see if it works now. I did see the numlock LED flash. But nothing's happening. That's annoying. Let's see if we can turn it off with this. If it turns off with this. Okay, that means the Super I/O chip is working at least. Southbridge is probably fine. It might be incompatible with that RAM. I've never actually tried that RAM in it before. Let's take a stick out and see if that makes any difference. Of course, I don't have a speaker connected, so it could be doing a beep code. I might need to find a speaker somewhere. Okay, there we go. So this sticker RAM is either not compatible or faulty. Actually, that's ECC RAM. That might be why. Maybe it can't use ECC RAM. I don't know. Oh, that's good. Let's go into here. What have we got? It's the, what is it? The 24th today? Oh no, this is a backwards American style. So it'll be 12/24/2017. And we don't have a floppy drive. The time is 14:41, so we want 14:41. And Pentium 4 CPU, 3 GHz. Okay, so I thought this was a Core something, but it's not. It's a Pentium 4. Oh well, that's okay. Still better than the Celeron that is the other option I have. Should be on that. Disable. But there we go. That's how you replace capacitors on a motherboard, or I guess, well, really on anything else. It doesn't go into detail, obviously, of the actual selection of the capacitors and how to figure out what replacements you need. I may do that in another video some point, but you can find that kind of information online anyway if you're looking. Badcaps.net is a good resource for that. Yeah, so various different methods of desoldering and soldering in new ones. Yeah, hopefully that gives you some ideas if you're stuck or you just want to know how to do that. And hopefully that was interesting. Hopefully that's some use to you in some way, entertaining, informative, I don't know. Anyway, hopefully it made your Christmas a bit more interesting. Hopefully this will actually be out on Christmas. Yeah, anyway, there we go. Capacitor replacement on a board. Asus P5VDC-MX version 1.01G. All seem to go perfectly fine, I think. Anyway, Merry Christmas and see you later.